card is drawn from a standard deck of 52 cards. We're going to find several conditional probabilities. The first one is the probability that the card is a queen given that it is a face card. So one card with two attributes. This would be the number of cards that are both queens and face cards, divided by the number of face cards. Well, there are 4 queens that are face cards, one from each suit, and there are 12 face cards, 3 from each suit. This reduces to a probability of 1/3. The second example is the probability that we have a king given that it is a diamond. Again, one card with 2 attributes. So this is the number of cards that are both kings and diamonds divided by the number that are diamonds. Well, there's only one that is a king and a diamonds. That's the king of diamonds. But there are 13 diamonds, and so the probability is 1/13. The third part, the probability that the card is a diamond given that it's a king. This is a different answer this time because even though the numerators are the same, the denominators are different. Here it's the number of cards that are both diamonds and kings, which is still 1. But this time the sample space will have the number of kings be associated with the number of kings, which is 4. So this time we have 1/4. So let's go to the second problem. Here we have a jar containing balls that are colored and numbered. We have 8 red balls, numbered 1 to 8, and 9 green balls, numbered 1 through 9. One ball is drawn at random from the jar, and we're asked what's the probability that the ball is red given that it has the number 1. So this would be the number of balls that are red and have the number 1 divided by the number of balls that have the number 1. Well, there's only one red ball that is numbered 1. There are 2 balls numbered 1. One is red and one is green. So the probability is 1/2. Part B, what is the probability that the ball is green given that it is numbered 9? Well, this is the number of balls that are both green and numbered 9 divided by the number that have the number 9. Well, there's only one green ball that has the number 9, and there's only one ball that has the number 9. It happens to be green. So we get 1/1 or 1. So we have a 100% chance, certainty, that the ball is green if it is numbered 9. Part C, what's the probability that the ball is red given that it has an even number? This would be the number of balls that are red and have an even number divided by the number that have an even number. So there are 4 even numbered red balls. There are 8 even numbered balls altogether, 4 red and 4 green. This reduces to 1/2. So half of the even balls are red and half are green. What's the probability that the ball is even or has an even number given that it is red? So this is the number of balls that have even numbers and are red divided by the number that are red. Well, we know that there are 4 even numbered red balls. There are 8 red balls altogether. So again, this has a probability of 1/2. Once you have a red ball, there's a 50% chance it is even, has an even number. Now, the last question in this group is a little bit different because instead of drawing one object, we're going to draw 2 and look at the probabilities, the conditional probabilities relative to the second ball. So this time we have a jar containing 7 red balls numbered 1 through 7 and 8 green balls numbered 1 through 8. So our first question is, what is the probability that the second ball is red given that the first is red? So this is going to be a slightly different process. Here we will have the number of red remaining divided by the number of total balls remaining. And so there were originally 7 red balls. One of them has been removed, so there are 6 left when the second one is considered. And instead of 15, there's a total of 14 left. So this reduces to 3/7. Part B, the probability that the second is red given that the first is green. So this is the number of red remaining over the total number remaining. And since the first ball was red, there will still be 8 green left. I'm sorry, I did that the wrong way. Since the first one was green, there will still be 7 reds left out of a total now of 14, giving a probability of 1/2. Part C, probability that the second is even given that the first is odd. So this would be the number of even remaining over the number of balls remaining. So since the first one was an odd, the number of even balls remaining is the same as what it started out to be. there would be 3 even red balls and 4 even green balls, so 7. And so we have 7 over 14, or 1/2. And lastly, the probability that the second is even, given that the first is even. This would be the number of even remaining divided by the number remaining, total number remaining. We started out with 7 even, and we've picked 1 even out, so we now have 6 even left and 14 left, which reduces to 3/7.